In this second video on factorizing, we're going to look at putting an expression into two sets of brackets. This is often known as factorizing quadratics and is a little bit more difficult than factorizing into single brackets from our previous video. However, I'm going to show you a couple of tips and tricks that will get you through even the most difficult ones. So a quadratic, if you didn't know, is just some sort of algebraic expression that has an x squared term in it, and that term is actually the highest power of x. We put it into double brackets, and that's how we factorize it. We do that by solving some sort of number puzzle where we need to find two, usually whole numbers, that add to make some part of the quadratic and multiply to make the other. If we look at this first example here, x squared plus 8x plus 12, we want two numbers that add to make positive 8 and multiply to make positive 12. So if you think about it for a bit, remembering that they're usually whole numbers at this level, those two numbers are going to be positive 2 and positive 6, which are added together to make 8 and multiplied together to make 12. So they form the second part of our quadratic when we factorize it. So I'm going to write this in two sets of brackets like this that are being multiplied together, and I'm going to put x at the beginning of each of these brackets. I'm then going to put my numbers in. They're both positive, so I'm going to write plus 2 and plus 6. And I can write those in either order if I wish. So that's been factorized. Let's just check that I did that correctly by expanding it as we saw in our previous video. So I'm going to expand term by term, following the arrows. I get x squared plus 6x plus 2x plus 12. Notice there in that last step that I multiplied 2 and 6 together to get 12, just like I did over here. And also when I simplify this, I'm going to add these two terms together to get x squared plus 8x plus 12. So I'm adding 2 and 6 together to make 8, just like over here. And that's why we have to do that little puzzle. It reverses the expanding process. Let's look at the second example, x squared minus x minus 6. There is a coefficient of minus 1 in here. We just don't write it usually. So I need two numbers that add to make minus 1 and multiply to make minus 6. Those two numbers, after a bit of thinking, are going to be 2 and 3. However, I need this one here to be a negative because 2 times negative 3 makes negative 6. But adding those together, 2 plus negative 3 makes negative 1. That's why the negative needs to be on the 3 and not on the 2. So let's factorize that. Which you can expand in the same process as before to see that we do have the correct answer. Let's look at two special types of quadratics. The first type is called a perfect square. Now it's factorized in exactly the same way. However, you can factorize it a little bit further, so it's important to show these ones off as well. The two numbers that add to make 2 and multiply to make 1 are actually 1 and itself. So x plus 1, x plus 1. So the two numbers are the same, and because our two brackets are the same, I can actually write this as x plus 1 squared, which you might remember from a previous video, that these two are actually the same thing. So we call it a perfect square because we have two brackets being multiplied by each other, and those two brackets are the same. This one here, it's also a perfect square, so our two brackets will be the same. In this case, our number is going to be negative 3. So we can write that as x minus 3 squared. Now the second type is a little bit more difficult. It's called a difference of two squares. We call it that because each of these terms here are actually all squares. They're squares of either x or some number like 1 or 5. We call it a difference because they're being subtracted. So they look a little bit different, but actually they're actually just x squared plus 0x minus 1. But we usually just don't write 0x in there. However, what that means is that we need two numbers that add to make 0, so they cancel out, but they multiply to make, in this case, negative 1. Those two numbers are going to be x plus 1 and x minus 1. So they cancel out because they add to make 0, but they multiply to make negative 1. And that's how you factorize a difference of two squares. The second one will look like this for the exact same reasons. And that's it. That's how we factorize normal quadratics and a perfect square and also a difference of two squares. Thanks for watching.